Hello friends, we are coming to our next lecture of linear algebra and the topic was matrix and its properties. So in previous classes we defined the matrix and also give some example of matrices. Now some another matrices. First one is the orthogonal matrix. What is the orthogonal matrix? If A is an square matrix and satisfies these properties, A transpose plus A equal to A transpose A equal to identity, then it is called a orthogonal matrix. Now we can say what is the transpose of a matrix. If A is a matrix A, B, C, D, then the transpose of matrix A is written as A row and column interchanged, means this is AC in column, so it's right in row AC. This is in second column, so right in second row BD. Or you can say this is in AB in first row, right in first column, so this is AB. CD in second row, so right in second column, so CD. It is actually mean the trans tr- uh, transpose. Okay. Now you can take an example where B is minus 1 0 0 0 0 minus 1 0 1 0. So B transpose is minus 1 0 0 in first row, so you have to write in first column, so minus 1 0 0 0 0 minus 1 in the second row, so you have to write in second column 0 0 minus 1. Similarly 0 1 0, so B and B transpose we have write. Now in previous classes we already seen how multiplication is done. So B transpose into B, this is B transpose matrix, this is B matrix. Now multiplication of this minus 1 minus 1 1 0 0 0 0 0 0, so that's why my 1 plus 0 plus 0, that is 1. Then this row and this column if you multiply, then this is 0. Then after all the multiplication we get this matrix minus 1 0 0, sorry 1 0 0 0 1 0 0 0 1, and it is the identity matrix of order 3 cos 3, and which is we write I3. And since B transpose B equal to I3 or I, so we can say that this is a orthogonal matrix. Okay. Next is transpose of matrix. What is the transpose of a matrix? Before knowing the actually we already done the transpose of matrix, because in orthogonal matrix the transpose is necessary. Okay, so we already say the transpose of matrix, so we skip that. Next, conjugate of a complex number. What is the meaning of conjugate? If z is equal to x plus iota y is a complex number where x and y are real entries, then x conjugate is written as x bar, and which is x plus iota y's bar, and which is written as x minus iota y. Okay. Next, for an example, if z is equal to 4 minus 6 iota, then the conjugate of z bar is 4 plus 6 iota. Okay, and conjugate of real number is same real number. Next is conjugate transpose of a matrix. What is the conjugate transpose? That means first of all you have to know the conjugate and you have to know the transpose. Okay, so the meaning of conjugate transpose means which is defined as a star or a theta, which is first of all we have to conjugate the number and then transpose. That means, or you can say first of all you transpose then conjugate the matrix. For an example, you can see this is a matrix A, 2 plus 3 iota 5 3p 2 minus 5 by 3 3i 0 2. Okay, and A transpose, first of all you have to do, sorry, A conjugate means where iota is present, that means where complex number is present we have to conjugate that number. So 2 minus 2 plus 3 iota is a complex number, so the conjugate of complex numbers 2 minus 3 iota. Here minus 5 iota is conjugate is 5 iota, and all are real numbers, so we doesn't need to change any number. So this is the conjugate of the matrix. Now the transpose of the matrix, if we take the transpose, then it's called the conjugate transpose, which is defined as a theta which is 2 minus 3 iota. This row we have to write it here. So 2 minus 3 iota, this is 5, this is 3p. This is 2 5 3, we have to write 2 5 by 3. This is minus 3 iota 0 2, so minus 3 iota 0 2. Here also actually there is 3i, this is also a complex number, so the conjugate is minus 3i. Okay. Next, is symmetric matrix. What is symmetric matrix? If any matrix of order n cross n, this can be 2 cross 2, 3 cross 3, anything. Generally we defined by n cross n for definition. If A transpose is equal to A, that means if we take any matrix and we do the transpose of the matrix and we get the same matrix again, then it's called the symmetric matrix. For an example, A is equal to A, B, B, C. A transpose of A is equal to AB, we write here. So AB, BC right here, BC. Now you can see A and B are equal. So this is the symmetric matrix. Now, skew symmetric matrix. What is skew symmetric matrix? If any matrix where A transpose is equal to minus A, means if we do the transpose of the matrix, then a minus is coming in front of this matrix, like A is equal to, also there is a point, the diagonal element of skew symmetric matrix is always 0. Okay, here skew symmetric matrix is 0. Example, 0 minus 4 4 0. Okay, now A transpose is equal to 0 4 minus 4 0, and which is equal to minus A. Am I right? So this is a skew symmetric matrix. Now Hermitian matrix. A theta means the conjugate transpose of a matrix. If we did conjugate transpose of a matrix and if we get the matrix again, then it is called the Hermitian matrix. And always you have to remember the diagonal element is always real. Since we are taking conjugate transpose, so complex entries is coming in this matrix, but the diagonal entries will be a real number. For skew Hermitian, similarly like skew symmetric matrix, if A theta equal to minus A, then it is called the skew Hermitian matrix, and the diagonal entries is purely imaginary or 0. Okay, it can't be a complex number, like complex number, but it's like iota y type or 0 type. It's not A plus B iota where A is non-zero, then this kind of thing, this kind of number can't present in the diagonal. Okay, next, some properties of transpose of conjugate transpose and conjugation. Like first one, A plus B transpose is A transpose by B transpose. A B transpose we write reversely, B transpose A transpose. If K is a constant, K A transpose, K constant is of outside of transpose, and K A transpose, A transpose, then transpose is vanished, and this is A. Similarly for the conjugate transpose, A plus B star equal to A star plus B star, you can write also by theta. Okay, A plus AB star equal to B star A star. Similarly K star equal to, since this is a complex number, so we have to write here conjugate, because in complex number alpha is conjugate of alpha. Okay, so alpha conjugate, alpha bar and A star, and A star equal to A. Okay, now next is unitary matrix. What is unitary matrix? If A star, that is conjugate, complex conjugate, okay, A star A and A star is equal to I. Like similarly our orthogonal matrix where transpose is present, and here complex conjugate is present. If A star A equal to A star, then it's called the unitary matrix. For an example, if A is equal to I00 iota, then A star A, after calculation you can see it is 100 iota, which is iota, so it is a unitary matrix. Now, normal matrix. What is normal matrix? If in a matrix A transpose equal to A transpose A, okay, then it's called normal matrix. That means every idempotent matrix is a normal matrix, you can say, because it's the basic, because it is a one part of the idempotent matrix. No, it's not equal to iota, but if these two are equal, then it's normal matrix. Every symmetric, schizometric, orthogonal are also the normal matrix, like Hermitian, skew-Hermitian, unitary. This is also normal matrix. For an example, A is a matrix, A transpose this, so A transpose A and A transpose A both are equal, you can see, so it's a normal matrix. Next is idempotent matrix. What is idempotent matrix? A be a square matrix. Okay, you have to take more than 95% of the question in matrices are coming from a square matrix. Okay, if A be a square matrix of order n, then A is known as idempotent matrix, like A square is equal to A. If A be a square matrix of order n, okay, and A is known as the idempotent matrix if A square is equal to A, means if we multiply two matrix, then it comes one matrix, means A is a matrix and you multiply by same matrix, then come the matrix A again. A is idempotent, then A to the power k equal to A. It's obvious. Okay, now converse part of the above result. If A to the power k equal to A, k belongs to natural number, then A is may or may not be idempotent matrix. Yes, like A to the power 5 equal to 0. A. Now you can't say that A to the power 4 equal to A. It is not possible. It can be possible, but not always. No. For an example, A is minus 1001. Now A cube equal to A square is not equal to A. It is identity, but uh, A square is not equal to A, so it is not idempotent. Some questions. Number of diagonal matrix of order n which is idempotent. Uh, Number of diagonal matrix. How many number of diagonal matrix of order n which is idempotent? N is equal to 3. Okay, for basic example, now you can see here for n. Okay, number of diagonal matrix, so we get generally for n, diagonal is a11, a22, a33, ann. It can be 0 or 1. Am I right? Why? Because for idempotent, it can be 0 or 1, 0 or 1, 0 or 1. So possibility of a11 is 2, this is also 2, this is also 2, so this is n times, so to the power n. Okay, now nilpotent matrix. A to the power k equal to 0, but a to the power k minus 1 is not equal to 0. For k is any natural number, then k is the index of A and is index of nilpotent matrix. Okay, it's easy. Now properties. First properties is A be an idempotent matrix of order n and determinant of A equal to 0 or 1. Okay, idempotent if A is idempotent matrix, the determinant either 0 or 1. Here you can see determinant of B equal to k, and idempotent means A square is equal to A, both side determinant, so A square is equal to A, so A square is equal to mod A, and so determinant of A is equal to k, so k square minus k, and k into k minus is 0, that means k either k equal to 0 or k equal to 1. Next, for idempotent matrix A, I minus A is also idempotent. Okay, if A is idempotent, then I minus A is also idempotent. and a square is equal to a square is equal to a. So I minus a square is equal to I square minus 2i into a square, that is I square minus 2a plus a square. So I minus 2a plus a, so I minus a. Okay, so I minus a is also idempotent because it is like also a square minus a. And also some example you can see. A is idempotent matrix, then rank of a is equal to trace of a. A is nilpotent matrix, then rank of a, determinant of a equal to 0. Also a is singular and non-invertible. If a is nilpotent, then trace of a equal to 0. This is the result you have to see, and in next lecture we'll see some more on linear algebra. And till then, thank you, bye.